My name is Ather Beg, and I'm one of the authors of the Intel white paper, Digital Infrastructure at Datacenter Scale, that we are showcasing today. I'm a blogger and podcaster, and you can reach me through the Twitter handle, Ather Beg, and my blog is atherbeg.com too. And you can also find me on LinkedIn. Having a unique name actually means that it's quite easy to find. Now, I've contributed a few pieces to this white paper, but in this presentation, I'm going to focus on the section called the perfect configuration. I felt the need to write it because there is a narrative being pushed by some companies that the best processors are the ones that have the most cores or the most clock speed, and your systems must contain those processors if you want to get the maximum performance out of your data centers. And I'm here to make the case that such a view is short-sighted. And most organizations, and especially service providers who buy a large number of servers for their data centers, don't particularly care about having the fastest processor. They understand that there are many factors that make up the perfect configuration fit for their needs. And while the processor is an important part of the overall performance of a system, the best configuration is only achieved if you look at it as a whole and optimize all the components accordingly. And in addition to making that case, I will also provide some recommendations in that section for a hypothetical system that aims to represent such a configuration. And it's all based on publicly available information for performance and configuration by Intel and VMware. Now, I'm a big fan of marginal gains. And if you follow cycling, you've probably heard of Sir Dave Brailsford, who was the performance director of the Great Britain cycling team, leading them to 8 gold medals each in 2018 and 2012 Olympics. And later, he became the manager of the team Sky and took them to victories as well at Tour de France for a few years after that with different cyclists. And in all those successes, his mantra has always been to break down all the steps into what goes into a cycling race and make improvements in them, because all of them, even 1% improvement at multiple stages, accumulate into a significant difference when you put them all together. And there is no better example of that principle than what we see in my favorite sport, Formula One. And I'm sure Max's favorite sport, or one of them, is that too. It is the pinnacle of motorsport, and for good reason. Now, every car in current regulations is powered by a 4-stroke 1.6-liter V6 engine, and the maximum permitted RPM is 15,000. Now, the specifications are same for every team, but every manufacturer tries to have their best to have a minor power advantage, and they design their engines that way and gain about 0.1, 0.3 seconds or so per lap generally. But then there are genius level aerodynamicists who can design a car that could potentially gain them a similar margin, again, 0.1 to 0.3 seconds or more, depending on the car. Then there are 3 types of compounds, tire compounds. And getting them right also gives you, your team, an advantage of 0.2 seconds per lap or more at times, depending on the strategy. Again, race and pit stop strategies can create, again, a similar kind of difference of 0.2 seconds per lap or more overall over the course of a race. And finally, the world-famous 3-second pit stops can potentially be the biggest factor whether a team wins a race or not, because it can make multiple seconds difference. And race is typically 50 to 70 laps long, depending on the distance. So all of these saved fractions actually make a difference of just a few seconds over a race. But those crucial seconds ultimately decide the race. This year, Ferrari is believed to have the fastest car and engine package over a single lap. And they've actually had most pole positions, like 8 pole positions out of 13 races. But they've only won 4 races as compared to 9 by Red Bull Racing. Because you see, the engine is not going to guarantee that Formula One team will win the race, it requires, or any other race for that matter, it only requires margin gains in every aspect of the race, and the team that gets most of them right ultimately wins the race. Now, you know, you're thinking where I'm going with this. Use the same analogy for the processor as well. Because while the processor, if you think of that being the engine of a system, it might well have a performance advantage in terms of cores or higher clock speed, but that's not just the only factor that provides that performance. There are many other factors as well. And now they might vary based on the requirements you have, but ultimately, all of them matter to a varying degree. And the white paper, that the section actually talks about those things in detail. And I will not go through all of them. I hope that you will read the white paper, but I will take you through a few examples of them. And what's important to focus on is not the technologies or the examples I'm going to give, because technologies and techniques do change over time. It's the principles I'm talking about that actually don't, and that is the focus of the entire presentation. But let's start with cost first. If the aim is to run VMware vSphere on your environment, one of the factors that having more than 32 cores in a processor that you're running in the system is going to be inefficient cost-wise because of the way vSphere 7 licensing works. And there is a reference in the white paper for that as well. And that essentially means that a dual 32-core processor in a system is optimum. Now, this is important because a hypervisor, if that's vSphere, licensing actually makes up a significant cost portion of the cost of the entire system. Now, 32-core processors have been around for a while, so they are quite cost-effective these days. And I've recommended a few in my in the section as well. And if you use some of them for your workloads, it might save you a fair amount because you're not going for the fastest processor because it has a price premium. Now, if you think about architecture, for example, another point, we can look at the third generation Intel scalable processors. And especially when you pair them with the pairing, Optane persistent memory 200 series, which is the right pairing with it. When you put them together, you can actually go beyond the native capacity of that host, which then allows you a better user and VM density. And you can even host bigger VMs as well on the same host that you would otherwise be able to fit. In fact, the maximum memory capacity and bandwidth option in this case, if you take that on a dual CPU system, would even allow you to go from a 1 terabyte configuration in terms of RAM to a 2 terabyte on the same host. And half a terabyte of DRAM will go into that system, which will make the cache, and 2 terabytes of Optane pre-mem will go into the system as the system memory. So if your main constraint for the workload is the total RAM capacity, suddenly you find that you only need half the number of hosts. Now, of course, fewer hosts also mean substantial saving on costs associated with all the other components that go into building a system as well. Like, for example, rack capacity, cooling, utilities, as the peripherals and motherboards also take roughly about 30% of the power, which again saves on cooling, and other operational costs as well. That you less number of hosts you need to run, the lesser the cost for operations. Now let's quickly move through towards performance as well, because that's another interesting factor. If your deployment runs on vSphere again, and you're looking to run vSAN as storage, you will gain a significant performance boost by not only using 2 disk groups, which is quite common, but also use Intel Optane SSDs as cache devices. And that's because the typical NAND that we normally use as flash devices for cache, they require a programmed erase cycle before any data can be written to it. In case of Optane SSDs, they don't require that because they have a write-in-place technology, which provides a lot more throughput than NAND devices. In fact, it's such a difference that you can actually get away with half the amount of cache, like 400 GB instead of 800, which also helps with cost, by the way. And this kind of configuration is actually particularly suited to write-heavy workloads, on which NAND might actually struggle if it becomes too heavy. Now, things to note is that Optane SSDs can also have 16 times more endurance than a NAND flash SSD, which means Optane SSDs are very likely to outlive the host they're living in, right? So regardless of how much write throughput you actually throw at it, it will outlast the server, which basically means that you will not have to replace them as often, or maybe never. So you reduce downtime or eliminate it, but also cost saving as well. So that's another operational benefit that you get. Now, network performance and flexibility is another one that I would like to mention. The Intel Ethernet 800 series that runs on PCIe 4 has the flexibility of speed configurations. So you can start with, say, dual 100 gig, but you can have other permutations at a lot lower speeds. But that performance is very useful because I know they also support RDMA and Rocky V2, which is very, very beneficial to the newer generation of vSAN configurations, especially if you're using HCI mesh in your vSANs as well. So again, that performance matters a lot when such configurations are being used. And in terms of performance, innovation is happening quite fast. There are technologies like infrastructure processing units, or IPUs, which service providers are already using in their cloud infrastructure to reduce latency in many areas. Like, if I remember correctly, Intel Mount Evans IPU is developed in collaboration with Google for their Google Cloud Platform. And Microsoft has also used them in their Azure data centers. And in fact, up to 5% latency improvements have been made using IPUs in some cases. And we are already hearing about CXL standards and the impact that is going to have on the future hardware whenever it starts coming. So there will be an enormous scope for infrastructure performance gains when that happens. So Intel being at the forefront of it does bode well for the future of such hardware. Now, in terms of additional features, that's another main thing that you need to consider. Intel has introduced security features into their processors, which is on top of the TPM2 chip, which is pretty standard these days. For example, there's an Intel Trusted Execution Technology, or TXT, which works in conjunction with TPM to provide hardware-based trust attestation at the BIOS, OS, and hypervisor levels. In addition to that, we have Intel SGX, for example, which is a set of new instructions that allow developers to partition their application in enclaves, which is placed into trusted memory, where applications can run in an encrypted state and in complete isolation. Now, okay, admittedly, that security is not needed by everyone. It's probably just mostly for military-grade applications or highly sensitive commercial applications. But it's good to know that the technology exists should you need it.
So my background is very, very heavy VMware design and architecture. I'm a VMware certified design expert. And I agree with everything you said here, right? There's a tendency to say, I want the latest and greatest of that one, without people stopping and looking, well, what are my workloads that I'm going to be running? What are my requirements I'm trying to meet? There's just this weird tendency. So a lot of things I'll see is people not looking at their workloads. And, you know, if I go and get whatever fastest processor out there, but my workload is RAM intensive, that doesn't really help me, right? So I guess it's silly, right? Like, people don't take the time up front. And I guess I'm kind of curious, what do you kind of attribute some of that to, right? Because I see the same thing. I see a lot of people, well, I just want the biggest, fastest, latest, and greatest. And that will give me the best performance of everything, right? They don't understand this bigger picture. So why do you kind of think that we keep on seeing this problem so much?
I think it's more hype actually. I mean, obviously it's my
It's not hype.
view. It's more hype that, if for example you're going just by whatever marketing tends to churn out, and you are you trust a certain publication and those kind of things, then obviously sometimes there is bias. And I think the best option is to actually look at all the specifications and think about, what is it that I need? Do I need performance in this particular area? Really? I mean, do I need that many cores? Is my workload going to be like?
I mean, if your workload's not going to use them, there's no point, right? Like
exactly. And or for example, that core licensing point I was making. If you have 40 cores in a processor, then you have to put 2 licenses on it, for example, right? And you're otherwise you're wasting cores. And all of these kind of things do matter in the longer run when you have a bigger,
especially when we're talking at like data center or cloud or enterprise scale, right? All these little things add up, and that's going to be like the Formula One analogy again, right? That's the difference between kind of going off the track and actually winning.
Exactly. And that's why it seemed apt to, use that as an analogy.
I love it, yeah.
Oh, thank you. But yeah, it's again, those marginal gains in everything like cost, performance, and like features I'm talking about, and the other two that are coming up, that, that I think are important to look at. So continuing, so those tech arguments obviously could be a bit heavy, so I thought I'll throw in another analogy here. So there are a few engine manufacturers in Formula One that run their own engines, own teams, as well as supply engines to other teams. And by regulation, they are required to provide the same engines to their customers as they use themselves. So Mercedes and Ferrari are the two most, the teams that provide most customer engines. Mercedes provides engines to McLaren, in addition to using themselves, of course, Aston Martin and Williams. And Ferrari serves Alfa Romeo and Haas teams. Now, despite having the same engines as their customers, it's always the engine manufacturer team that is at the top of the standings in each championship year amongst those teams. And that's because the research and work done on the engine means that they are way ahead of their customers in knowing the most efficient engine modes and aerodynamic, cooling areas, or other technical configurations. So again, if we use the same analogy, if you are going for a diverse ecosystem products, that's always the best policy. So because while hardware from different vendors does work together because there are common standards, hardware from the same manufacturer has a marked advantage. And that's because of the optimization that you get from the regression testing of all permutations of hardware that they can do. And not only that, but having a diverse ecosystem allows the manufacturer to introduce optimization and compatibilities into the ecosystem components long before the beneficiaries of those components even come into existence. And that also helps with operations. I'm sure that you've seen many examples where the new hardware often precedes the introduction of that hardware itself. So as the technologies are developed by the manufacturer, that kind of a manufacturer can roll out those firmware and drivers into the operating systems and hypervisors that prepares its customer base for the upcoming innovations. And that capability is a major benefit for customers operationally because they find that the software support is already existing in the various hypervisors and operating systems they use by the time they get the hardware. Now, finally, it is crucial, and in fact critical, I would say, to minimize the number of manufacturers where possible. And that strategy minimizes supply chain and support issues. It is not uncommon to see finger pointing between different vendors when multiple manufacturers are involved in an incompatibility or bug, which causes major delays and inconvenience whenever you're troubleshooting. So optimization is required to extract performance out of all the components that makes a system, which includes tangibles like cost, performance, and features, but also strategic decisions like going for a vendor with a diverse ecosystem and optimization of operational issues by minimizing vendors. it is the sum of the marginal gains in all those areas that give you the perfect configuration. So in summary, the largest core count or the highest clock speed of a processor doesn't mean much because it's just one piece of the complex puzzle that makes up the ideal system to meet your future needs. Remember that the highest team that I was talking about, for example, that uses a Ferrari engine, but it's 7th in the team standings out of 10. So think about it. Your buying decisions need to be made by looking at the bigger picture and optimized based on cost, performance, and feature richness. But also it's crucial to go with a hardware manufacturer that has a diverse ecosystem, because doing so ensures the maximum optimization of performance between components while minimizing the risk of incompatibilities and therefore support issues. It's only when both of these strategies are combined that you get the best chance of creating the perfect configuration for your needs, and one that will serve you well while designing the data center of your future. So with that, I rest my case. I thank you for listening, and we'll be glad to answer any questions that you have any comments. Also, please do remember to go and read the white paper, which is Digital Infrastructure at Datacenter Scale.
I want to bring up the elephant in the room, as it were, because you pointed to Optane memory as being sort of a key component to the perfect server that you were outlining. And I know that recently Intel has stated that they are discontinuing development of the Optane line. So I'm curious what your thoughts are in regards to that announcement and how that impacts the design of the perfect server that you were outlining earlier.
Right. I mean, of course, everyone has heard that. And to be honest, I'm not that concerned. And the reason is this, because while the announcement has happened, it's not a new thing. I mean, when the announcement happens, it takes a very long time for the supply chain to go out, right? And like I said, these were just examples. Today it's Optane, tomorrow it'll be something else like CXL-based technologies and everything else that's coming out. Optane has provided it's a unique solution, right? Mm-hmm. It's a very innovative solution. And I'm sure the Intel has taken those learnings from that. So I already know, for example, in the IPUs that I was talking about earlier, Intel is already using the emulation of the NVMe techniques that they learned while developing the Optane side of things. So those learnings actually, it's always the case with manufacturers that those learnings actually move on to the next technology. And by the time that you start running out of Optane in the market, for example, in your configurations, I'm sure that those new devices will be coming out. So I'm not that concerned, but like I was saying, that this is just examples of the point I'm making is also not just Optane. Optane is obviously a good example in this case. It's also about everything, every stage of the configuration that you build eventually for your data center.
I see. So you're making the case that even if Optane itself doesn't continue, the lessons learned and the ideas unlocked by just the concept of Optane will apply to new technologies.
Yes. And that is definitely not only true for this particular case, but I think it's for all technologies that come after the ones preceding them.
Right. I was reading something where they were sort of describing that if not this iteration of CXL, the next one being able to have memory boards filled with DRAM being snapped into PCI Express slots, so you kind of move away from that limitation of the slots that are, directly mapped to a processor.
Correct. Yes.
That would be huge. Cool.
We're all looking forward to it.
The other thing I wanted to get your thoughts on and point out is there's a balancing act between going with a single vendor when possible and also the marginal gains that you get from implementing a technology from a specialty vendor that may not yet exist with the usual vendor that you go with. So how do you make that distinction, or how do you strike that balance between the marginal gain you get from going with a specialized vendor and then the additional overhead of working with that specialized vendor?
So obviously, I mean, if there is a need to gain that performance in which that particular vendor, which is not part of that ecosystem, it's a must-have, then obviously the pragmatic view would be to go with that vendor as well, because everything else that you're putting into the system will still be from that one vendor that you chose for. And well, in some cases, you will have other vendors which does actually provide that that kind of hardware. It only, I mean, it's only whatever is pragmatic. Again, the same concept applies that if you've maximized your performance on every other level, apart from that one hardware, because of common standards, it will work. So you still can go with it. The pragmatic solution would be to go with it, but you've still optimized. In a way, that doesn't go against the theory because you've optimized because that was the best card that you could get or best component that you could get. Mm-hmm. So it still aligns with the theory. It's just that going with the same manufacturer often actually gives you the advantage that those components are already optimized in most cases. And that's where you gain the most with the most compatibility as well.
Gotcha. So benchmark away, figure out what works the best, and think of it in the more holistic sense of we also have to now do the drivers and the updates and the firmware for this other vendor if we're going to incorporate it. But if the benefit is large enough from a performance standpoint or a, hey, this makes our company more money standpoint, then maybe that's what we end up going with.
Of course, yes.
Yeah, I have a question as well on the, some of the gains that you were talking about in terms of, consolidation, smaller data center footprint, savings on energy, and so on. If you're doing that at scale, obviously you're not going to run into much troubles when you're consolidating a lot of workloads. But if you're looking at a smaller scale, don't you think that reducing drastically the amount of hosts kind of lead into situation where the blast radius, in case you lose a host or a part of your environment, is larger than if you had, let's say, less consolidation gains? I'm thinking, for example, if you have, let's say, double the amount of VMs on a host, for example, thanks to this consolidation, can it impact, let's say, your whole environment? Isn't it rather a matter of how you design your environment and placement rules and so on to kind of mitigate that?
No, of course, that is absolutely true. And again, it's one of those design decisions that you come across that, if you are designing a system that's, for example, the minimum vSAN cluster or something on those lines, then obviously you need to think about what is my requirement in terms of failover or redundancy and all those kind of things. Then that's where your architecture side comes in. And if you're just restricted to 4 or 5 hosts, then maybe you're not thinking that much about reducing the number of hosts. Then your priority is resilience. But if we are talking about larger scale environments where you get like 50 hosts, 100 hosts, something like that, reducing them to half, for example, does actually translate into big savings and less operational costs. So it does work, it does make it worthwhile doing so. But you're right, that smaller environments don't necessarily benefit from such optimization, in which case resilience is more important.